My name is Darren Thomas. Welcome to our first video here on our course, Easier Practical Applications of Machine Learning Algorithms in R. And so here's the overview of what's going to be happening in Unit 1. We're going to be talking specifically here, you can see for yourself, about decision trees. And so we're in Lesson 1.1. We're going to do an overview of decision trees. Then we're going to, of course, do data preparation, model development, and lastly, model testing. So let's go ahead and begin with Lesson 1.1. where we take a look at an overview of decision trees. So what is a decision tree? You can see down here below we have a very clear picture of kind of how it works out. You have a root node, decision node, leaf nodes, etc. And then these guys right here, like that, these are our branches. That's what those are. So if you look up here at the bullets, a decision tree provides the user with a visual of how to make a choice based on certain criteria. So the important thing here is the visual aspect of it. That's what makes it very beneficial. And I've already talked about what's happening down here. So what's happening is that you have some sort of a criteria that divides the data into different groups, and then you have another criteria that divides the data further on, etc., etc. And so if you look at the second bullet, it tells you right here, the goal is to subdivide the sample into subsets that are highly similar within groups similar. And the measure for that is commonly used is entropy, especially for classification, because our first decision tree is going to be classification. So let's go ahead and move on here. But before we move, I want to make sure something's clear, that at the end result of making a decision tree when you're using R, you can make some sort of a visualization such as this. And right now we're talking on an abstract theoretical level, but when we get to the actual example, this will make much more sense. So let's move on. Now, as I mentioned, and this is data science in general for the most part when you're dealing with supervised learning, is that you have two ways that you can deal with things. Classification, in terms of your dependent variable is categorical, and regression, in which your dependent variable is continuous. And those are what we're doing. So an example of classification might be to separate men from women based on some sort of a criteria. An example of regression might be to somehow predict salary based on several criteria above it. These are all examples of what can be done with decision trees. Now in this first unit, we're going to be dealing specifically with classification. Classification models involving the use of a decision tree. And you can see here that there are several different types of algorithms that can be used. The one you use, we can argue forever about which is superior to the other, but some that are commonly used and that are available for your own particular use include RPart, C 5.0, Quest, and C-Tree. These are just some of the many algorithms that are available in terms of decision trees. And remember, what decision trees do is they divide the data into various subgroups based on similarity of the people within the group. Now, we're going to talk a little bit about some of the pros and cons of using decision trees. There are three pros here. You can see, first of all, is versatility. It's a very flexible algorithm that can be used in many different situations. Another main benefit is, of course, its ability to deal with missing data, which can be quite the curse for many algorithms that really struggle with that. But for decision trees, this is not a problem. And also, because of that beautiful picture that you get at the end, decision trees are very easy for the average person to understand. And so if you're in a situation in which you need strong performance that is understandable, a decision tree might be a practical solution for you. However, just like with everything else in this world, there are also cons or disadvantages to using a decision tree. For example, it is very common for decision trees to overfit the data. What that basically means, to make it as simple as possible, is that the algorithm, the decision tree itself, gets so good at understanding your particular sample that it is not able to generalize to other data. And this, of course, can be quite a problem. Another problem that you can often see, and there's ways to deal with this, just like there's ways to deal with overfitting, is complexity. Sometimes the tree can get very, very complicated due to characteristics of the data. And maybe if you're listening closely, you can see that there's a connection between overfitting and complexity. Generally, as the model gets more and more complicated, it is more and more prone to overfitting. And so these are the two main things that you have to try to balance, at least when you're considering some of the disadvantages of using a decision tree. So in this video, we just kind of gave you an overview of the direction of this first unit in our class. We talked about decision trees, what they are, the beautiful pictures that they make, the different algorithms that are available, as well as the strengths and weaknesses of using this particular style. So I hope that this was clear for you, and I look forward to seeing you in the next video.